Find the limit as x approaches infinity of 2x minus 5 times 3 plus x all over x minus 1 times x squared plus 3. All right, to find the limit as x approaches infinity, what we first want to do is find an n behavior model. And to do that, we do want to simplify these problems out. So if I have 2x minus 5 times 3 plus x, if I FOIL that out, I'm going to get 6x plus 2x squared minus 15 minus 5x, which will reduce to 2x squared plus x minus 15. And then in the denominator, if I FOIL that out, I'm going to get x cubed plus 3x minus x squared minus 3. Nothing to combine, but I am going to put it in standard form, so I'll have x cubed minus x squared plus 3x minus 3. And then from here, we are going to go ahead and take the highest powers from each. So my n behavior model would be 2x squared over x cubed. And if I reduce that, my n behavior model is going to be 2 over x. And if I find the limit as x approaches infinity of that behavior model, if I plug in infinity for x, 2 divided by a really, really large number will approach 0. So that limit will be 0. Number 26, let f of x equal x squared minus 9 over x minus 3 if x doesn't equal 3, and f of x will equal 5 if x does equal 3. And it says, which of the following statements about f are true? Before I do anything, I think it's going to be helpful if we have a picture of what this looks like, because it's going to make the answer make more sense. So going back to the very first chapter where we graphed a piecewise function, that's exactly what I'm going to do. So this function is going to hold true as long as x doesn't equal 3. So I'm going to make an xy chart for this one. And I'm going to pick 0, 1, 2. I'm going to put 3 on it, but I'll switch it. But then x can't equal 3, so I'm just going to cross that one off. There's going to be a hole there when I'm graphing this. Okay, so if I plug 0 into that upper function, I'm going to get 3. If I plug 1 into that top function, I will get 4. If I plug 2 in, I get 5. If I plug 4 in, I get 7. If I plug 5 in, I get 8. And if I plug 6 in, I get 9. All right, so I'm going to go ahead and graph what I found there. Let's see here. So 1, 2, 3. Okay, so 0, 3. And then 1, 4. And then 2, 5. And then 4. Skip 3, 4, 7, 5, 8, and then 6, 9. Okay, so you notice we're getting a nice straight line, but at 3, I need to make sure I put a hole because x can't equal 3. So that's what the function is going to look like. And then it says when x equals 3, it's going to equal 5. So that pretty much just means the 0.35, that's what's going on. So 3, 5, which would be about right. Going to be about right there. Okay, so then this is what the picture looks like. So now it is asking, does f have a limit at x equals 2? So if I come in from the left and if I come in from the right, is there a limit? Yes, there is. Okay, is f continuous? I'm going to say no, f is not continuous because there is a hole. So f is not continuous. And if f is not continuous, then it cannot be differentiable. So it is only one, which is choice A. Okay, number 27, find the limit as x approaches 2 of 3x squared minus x minus 10 over x squared minus 4. Okay, if you try to plug 2 into this equation, you are going to get 0 over 0. Doesn't mean there's not a limit, just means I can't do it that way. So instead I'm going to try to factor. So I will use the magic number trick for the top. Okay, 3 times negative 10 is negative 30. I'm thinking what times what would give me negative 30, but add to give me the negative 1 in the middle, and that's going to be minus 6 and plus 5. And then I'm going to divide the 3 out of that first part. So this will be x minus 2, 3x plus 5. And then in the denominator, x squared minus 4 would factor as x minus 2, x plus 2, which means the x minus 2's cancel, so I'm left with 3x plus 5 over x plus 2, and the whole goal in me doing that was to be able to plug in 2. So now I'm going to plug in 2 for all of my x's, and I will end up getting 11/4 when I do that.